All right, we are back and going to do the same thing we did for the 45-degree angle in the unit circle with a 30-degree angle in the unit circle. So again, I've labeled the radius with a 1. That's what makes this a unit circle. And the radius this time is stemming out from the center at a 30-degree angle. So 30-degree angle in all these quadrants. And the goal is to find the ordered pair where this radius hits the circle. So we want this x, y value, and we're going to make a right triangle to help us find this xy value. So stemming out from the center horizontally would be x, going up would be the y. We need to find those values. Because we have a 30-degree right triangle, the other angle is 60, we can use our 30, 60, 90 special right relationship to find our side lengths. Because I've labeled the hypotenuse as 1, remember in a 30, 60, 90, the hypotenuse is representative of 2 times n. N is always opposite the 30, so this makes opposite the 30, it's my y side, and it will be 1/2. Then if I go opposite the 60, that is the n side times radical 3, which is going to equal radical 3 over 2. You might remember this from yesterday's assignment when we did the intro. So I'm going to label my ordered pair as xy, radical 3 over 2, 1/2, and there's our ordered pair. So if we come over to quadrant 2 and we did the same thing, hopefully we realized from doing the 45, 45, 90 that we're going to get the same values. The x is still going to be a radical 3 over 2. The y is still going to be a 1/2 because the radius was still, the hypotenuse was still 1. So it's not going to change what these values are, but we do have to watch that their signs change because we're in a different quadrant. So the x is negative, but the y is positive. And if we did the same thing in the quadrant 3, we would find that we get the same x, same y, but they're both negative. So negative radical 3 over 2, negative 1/2. And in quadrant 4, the x is positive, but the y is negative. And now we're going to go through and we're going to identify the angles in radians and degrees at each of these points so that we start to see some familiarity with all the angles that go around in the unit circle. So obviously this was 30 degrees. Now if I take and go all the way around to the second quadrant, remember that x-axis is 180 and I'm 30 before that. This is 150 degrees. And in the third quadrant, I'm 30 after 180, so that would be 210 degrees. And then all the way in the fourth quadrant, I'm 30 away from 360, so that's 330 degrees. So all of these angles relate back to a 30 degree, and notice the ordered pairs are all linked together as well. Next is the radian. So we should remember that the radian for 30 is pi over 6. That's one of the ones I wanted you to remember. If you need to convert it still until you get that in memory, that's fine. And I don't want you to have to convert all the other degrees. I want you to use the special trick. So remembering that 180 is really pi, if we make a common denominator with our reference angle, which is 30 degrees, so pi over 6, I make the numerator 6 to adjust. And so now I'm essentially 1 pi over 6 before my 6 pi over 6. So this must be 5 pi over 6. And then in the third quadrant, I'm pi over 6 after 6 pi over 6. So that's 7 pi over 6. Now over here in the fourth quadrant, we need to compare to 360, which remember is 2 pi. If I make a common denominator over 6, the numerator adjusts to a 12. And that makes pi over 6 before that 11 pi over 6. So there is your degree and radian at each of your 30-degree marks around the unit circle, along with the ordered pair. I know it seems like a lot right now, and I promise we are getting to where we're going to make some connections, so just bear with me. We're building the unit circle. The sine of 30, cosine of 30, and tangent of 30. Again, you can use SOHCAHTOA. You can come right in here, zoom in, do opposite over opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent for your tangent. So that y was a 1/2. So if I do 30, I would do 1/2 over 1, which is just 1/2. If I did the cosine of 30, that adjacent side is a radical 3 over 2, and then dividing by 1 won't do anything. Tangent is opposite, which is 1/2, divided by adjacent, which is radical 3 over 2. This one you have to do some fraction work, so we're going to multiply by the reciprocal. So I took the bottom, flipped it, and multiplied. The 2's canceled. I get 1 over radical 3. If I rationalize that, I end up with radical 3 over 3. Now what I want to share with you is, because these trig functions are going to show up a lot, we are going to eventually talk about potentially memorizing or knowing how to get these values really quickly. Knowing that the sine of 30 is 1/2, how quickly can we get that? Knowing that the cosine of 30 is radical 3 over 2, how quickly can we get that? Usually just by looking at a visual, though sine and cosine come pretty easily. The tangent is trickier because you're dividing and doing some fraction work. So this is definitely one tangent that I would just really want to ingrain into my memory. So we'll talk about tricks and how to remember that the tangent of 30 is radical 3 over 3. Feel free to come up with your own. But that's one that you don't want to have to do the work for all the time. All right, moving on to our 60 degree, and we're going to again do the same thing. Find the ordered pair at the end of the radii in the unit circle, meaning the radii are each 1. And this time we want that angle to be 60 degrees off of the center to your radii. So we're 60 degrees in all the quadrants. And so if we draw in that right triangle and try to find our x, y value to make the ordered pair, we have another 30, 60, 90. It's just the triangle is set up different than the one we just made. So opposite the 30 is my n side, and that's where the 1/2 is going to be. So this time that 1/2 is the x, not the y. And then opposite the 60 is the n radical 3 side, which turns out to be radical 3 over 2. So what you'll notice for the 60 degree ordered pairs is they're just flipped from what our 30 degree ordered pairs were. And so then I can come over into quadrant 2 and do a negative x and then the positive y. In the third quadrant, they're both negative. And in quadrant 4, the x is positive and the y is negative. And then we can go ahead and fill out the degrees at each of these ordered pairs, 60. And then if I come all the way around, I'm 60 away from 180, that's 120. I'm 60 after 180, so that's 240. And then I'm 60 before getting to 360, which is 300. Now my radians. 60 degrees, one that we want to have memorized is pi over 3. And if we use the trick, using pi, but making a common denominator and adjusting the numerator, we're looking at a 3 pi over 3. The reference angle is 60, so it's just a pi over 3. So pi over 3 before getting to 3 pi over 3 is 2 pi over 3. Pi over 3 after getting to 3 pi over 3 is 4 pi over 3. And 360 is 2 pi. If I put it over 3, I adjust the numerator to 6. So pi over 3 before getting to 6 pi over 3 is 5 pi over 3. Guys, the radians aren't hard if you can get common denominators and compare to the x-axis. We're just using reference angles. right? And it's just a counting game. One connection that I forgot to mention when we did the 30 that we had made with the 45 is notice 30 degrees is always a pi over 6, and all the 30-degree angles are all over 6. It's all a pi over 6, just like the 45s were all pi over 4s. And notice the 60s are all pi over 3s. It's a great way to remember what reference angle you're referring to. If I see a pi over 3, I know it's got to be a 60 coming from a 60-degree angle. If I see a pi over 6, I know it has to be coming from a 30-degree reference angle. So again, cool connections, really cool patterns that we're seeing here. Sine, cosine, and tangent of your 60. So make sure you're just looking at a SOHCAHTOA relationship here. The sine of 60 is opposite, which is radical 3 over 2. Let me write that again. Over the hypotenuse is 1, so I don't have to worry about that changing anything. Cosine is adjacent, which is 1/2 over the hypotenuse, which again was a 1, so nothing changes there. The tangent, we have to divide the opposite over the adjacent. So here's your tricky math. Multiply by the reciprocal. 2's cancel. You're left with radical 3. Again, another one that I would just memorize like I set up here with the tangent of 30. They both are 3's. The one's radical 3 over 3, and then the other one is simply radical 3. So if you need to have some memory devices there to remember those and not get them confused, I will give some hints down the road, but you can also create your own. We're doing a great job. We have almost built the entire unit circle with all these ordered pairs and angles. The only thing we haven't looked at, we did 30, 45, and 60, the key angles, but we didn't look at the 90 degrees. All of these key axis angles is what I tend to call them. You already know the degrees and radians at all these points, but we haven't written down the ordered pair, and there's no triangle to make here. It's self-explanatory what the ordered pair is at these points because remember the radius is 1. So this ordered pair is 1, 0. The ordered pair at the top is 0, 1. The ordered pair over at the left is -1, 0. And then down at the bottom, 0, -1. If you need to write these angles in, just as a quick reminder here, this is 0 degrees, then we have 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So 0 and 360 share the same ordered pair. Your radian values, again, hopefully you're becoming pretty familiar with this. 0 degrees could also be 0 pi. 90 degrees is pi over 2. 180 is pi itself. 270 is 3 pi over 2. And then 360 is 2 pi. So you've now got the radian and degrees at each of those particular spots. All right, we have built the unit circle. I'm going to pause here, not pause, but I'm going to stop this video, and we've got one last video where we pull it all together and make some cool